All right, so just to give a couple other people a chance to come in late, I will go ahead and take questions now. Are there any questions? I believe Miranda, you have some.
I have a lot of questions, so.
I'll take some now, and then we're gonna do something else, and then we'll come
Okay.
back, and then we'll finish up the questions.
So I was looking at the chapter 2, like master set stuff, and I was just basically like, if there's somewhere online I can look to find like the formulas and stuff, I can do that, but I was having a hard time finding, like I watched some of your past lectures, just like looking for examples for this kind of stuff.
All right, so which,
So,
is it just in general about where do you find the equations, or?
yeah, that, and I can like ask specific questions if you need me to, but I just need like equations.
All right, so the main equations that you're gonna face in those problems is gonna be what are called the Kate formulas, the constant acceleration, kinematic equation. And I do call them the Kate formulas, even though the word equation is right there, so there's a certain amount of redundancy. So if there's constant acceleration, then the following equations can be used, and I think this takes care of a bulk of the chapter 2 and chapter 3. We have displacement, displacement is equal to VIT plus 1/2 AT squared. A is acceleration, V is velocity, S is position, delta S is displacement. Delta S equals VI plus VF over 2 times time. Then VF. Those are the four major equations. Then we get into a couple of equations that are slightly more universal, that the average velocity is the change in position over change in time, and average acceleration is change in velocity over change in time. That's supposed to be a delta there. And then average speed is distance over time, and then scalar acceleration is change in speed over change in time. So if you have not watched any of the videos yet, then this might look very foreign to you. So, I'm trying to think if there are any other equations really. Those are the main ones, definitely. Is there something more specific?
Well, on the first one, for example, it was saying like, don't calculate the effects of air. So for my understanding, if the balls are both the same size, but they're different weights, aren't they still gonna fall at the same speed, or no?
As each other, I assume you mean?
Mm-hmm.
They should.
Okay.
We can test that out easily enough. Now granted, they're not exactly the same size, but hopefully close enough. All right, so two objects. We'll pretend they're close enough to the same size. If I drop them at the same time, which is gonna hit the ground first? So and it really doesn't matter, if we're ignoring air, then, well, larger objects are harder to move, or sorry, more massive objects are harder to move, but they also have a greater force acting on them, so it balances out. Does that answer your question there?
Yes.
All right, other questions? I assume, Miranda, you're about to come up with another question?
No,
No?
good.
Oh, no.
I'm just reading.
Oh, I was thinking that you had a lot more. Okay. Well, 10 minutes killed right there. So let's go ahead and do this fun little exercise. Take out a piece of paper. This is not for a grade, this is just to figure out what you know and what you don't know. Please do not write on these. Please do not assume that any marks on these are an indication of a right or a wrong answer. And if you happen to get one that has marks on it, just let me know when you hand it back in. When you are done, bring up the test or the assessment and your answer sheet. Don't wait for me to call for them. It also gives me an idea of how many people are still working. That should take care of your problem. You're welcome. And it's 30 multiple choice. If for some reason you don't have 30 multiple choice questions, then you're missing a page. And we'll have class after we're done with this. It's going right. All right. Get to work in a moment. Make sure I write down this equation correctly. Equation right there. That's FP bar E bar over U N bar E bar plus. Did I write that down correctly? All right, this comes from that article that was flashed on the screen there by Nick Bostrom in 2003. He's a philosophy professor, I think from Oxford. And it's all about, are we living in a simulation right now? So I was reading this about 10 years after he put it out, and I get stuck on this. So let's define some terms here. FP is the fraction of all human-level technology civilizations that survive to reach post-human civilization. So he's basically working this argument that technology keeps evolving, becomes more and more sophisticated, and eventually some civilizations will make it to the point where they can create these incredibly complex computer simulations, and it is possible that he's claiming that we are actually living in a simulation. If you've seen The Matrix, you have some idea what I'm talking about here. So, FP is the fraction of all human-level technology civilizations that survive to reach post-human civilization. So you've got the FP, number of post-human civilizations out of the total number of, I'm going to say civilizations, it's actually civilizations with technology. N bar is the average number of ancestor simulations run by post-human civilizations. So average number of ancestor simulations per post-human civilization. H bar is the average number of individuals that have lived in a civilization before it reached post-human stage. So this is the number of people pre-post-human over average number per civilization, and that would be pre-post-human civilization. What's wrong with his equations? It does not require reading any more of his paper. What's wrong with the equations? Cooper?
Is it that if the numerator and denominator are the same with an added h, then h must be 0, which means the whole thing's 0?
We can assume that h is not 0, but that would be an issue. So we do know that h is not 0 because we are potentially pre-post-human. There had to have been somebody who lived before they got to that technology where they could create simulations. So I'm not faulting him on that, but if h bar is equal to 0, then yes, then we have this fraction of undefined amount. If we want to look at this equation right here, I just factored h bar out and canceled it. Here, FP stands for the same thing. Fi is the fraction of post-human civilizations that are interested in running ancestor simulation. So this is the post-human. interested in running ancestor simulations over the total number of post-human civilizations. And Ni is the average number of individuals, average number of, this is the average number of ancestor simulations run by the post-human interested, post-human civilizations, this would be civilizations, interested in running ancestor simulations. He claims to have a background in physics and math, and yet he forgot a very fundamental thing. So hoping somebody would see it. Let's take a look at units. What would be the units of F sub P? So in terms of notation, this is a notation, shorthand notation for units of, if we'll primarily be dealing with the SI units or international standard units, Standard International units, and so I would put the brackets around it and then put SI to indicate specifically a particular unit system. But this is not really falling into that unit system. So what would the units be for this fraction, based upon the definition over there?
Would it be the number of civilizations?
If you're stopping there, then no. All right, so let's say that the total number of civilizations is, there's 100 civilizations. That's supposed to be an L, civilizations. And the number of post-human civilizations has to be smaller than that. So let's say 30 of this 100, 30 become post-human. The fraction would be 0.3. Right, how did I get 0.3?
Divided by 100.
Yeah, just shout out when you got it. All right, so 30 of these divided by 100 of those, so it's post-human civilizations per civilization. I'm just going to abbreviate that. So this is FP N bar H bar over FP N bar H bar plus H bar. All right, so FP the units are post-human civilizations per civilization. So I'm obviously creating some units here. All right, N bar is the average number of ancestor simulations per post-human civilization. What would those units be? drawing board again. So we have these 30 post-human civilizations, of which we will assume that 15, now let's make it 20 run ancestor simulations. And on average, they run 4 ancestor simulations. What would the units be? Someone take a guess.
You mean like actual units or like you want us to like?
We're creating some units here. Legitimate units, don't just give it some name, but based upon the fraction over there, what would the units be?
20 divided by 5? How many 4?
That this is 20 of this 30 civilizations. This is 20 post-human civilizations will run an ancestor simulation.
Ancestor simulations per post-human civilization.
Yeah, there we go. I'm just gonna call it ANSIM per post-human civilization. And H bar which is the average number of people pre-post-human civilizations that lived in a pre-post-human civilization.